Hello viewers, welcome to my channel AK Concepts of Electrical Engineering.
Energy stored in a capacitor. As we know, the capacitor stores electrical charge on its plates. Capacitance C is given by Q by V, or we can write this as V equals to Q by C or Q equals to CV. While charging the capacitor, work is done by the external agency. The potential represents the work done on a unit charge. The potential work done on a unit charge dq, from which dw equals to v dq, that we can write q by c dq. At the start, q equals to 0. As the charging proceeds, more and more charge accumulates on the capacitor plates, raises its potential. Charge at the end q. The total work done in charging a capacitor W equals to integral dW, which equals to 0 to Q, that is final charge, Q by C dQ, then Q square by 2C, 0 to Q, Q square divided by 2C, Q by 2, Q by C, or Q by 2, Q by C is nothing but a V, half QV. W equals to, replace the charge Q with the formula Q equal to CV, then CV square divided by 2C. C, once C gets cancelled, then another C remains, half CV square. Energy or work, that is W, is given by half CV square, which equals to half QV, which equals to half Q square by C joules. Energy density. The energy density in an electric field is defined as the energy stored per unit volume. Energy stored in the electric field is between the plates of a capacitor. Now let a small cubical volume, that is delta V, considered in the field, and let the energy stored is denoted by delta W. W is given by limit delta V tends to 0, delta W divided by delta V. In the previous video, we have seen that energy W is given by half CV square. Capacitance for parallel plate is given by epsilon A divided by D. E equals to V by D, from which V equals to ED. Now substitute in this. W equals to half epsilon A divided by D into V square, that is E square into D square. Then D square gets cancelled. This is half epsilon E square into A into D, which is nothing but a area into distance, is nothing but a volume. So half epsilon E square into volume V, small amount of energy for small amount of volume, which equals to half epsilon E square. Then when this delta V tends to 0 limit, then this equals to W, that is equal to half epsilon E square is the energy density, joules per meter cube, from which we can write W is equal to half epsilon E square, that equals to epsilon E is nothing but a D, half d, that equals to E is d by epsilon, so half d square by epsilon joules per meter cube. Let us solve one problem. That a parallel plate capacitor of 10 centimeters into 10 centimeters and the thickness of 1 centimeter is charged to a potential of 1 kilovolt with air as a dielectric. Find energy stored. And secondly, C is disconnected from the source and a dielectric slab is inserted in the capacitor with the ER equals to 4. Calculate the energy stored W. Now, solving A, W equals to half CV square. And we have the formula C equals to A epsilon naught D. Then W equals to half A epsilon naught D into V square. Then substitute the values. Half A 10 centimeters into 10 centimeters, that is 100 centimeters square, that is nothing but 0.01 multiplied by the epsilon, that is 8.854 into 10 to the power of minus 12 divided by D is 1 centimeter, that is 0.01 multiplied by the voltage, that is 1 kV, nothing but 1000 volts square. Let's cancel. 1000 square is 10 to the power of 3, 10 to the power of 6, 10. This one is, let's cancel, minus 6, 4.427 equals to 4.427 into 10 to the power of minus 6. Energy stored is given by 4.427 microjoules. Now for our second problem, capacitor is replaced with the dielectric slab of relative permittivity 4. Then W is equal to half CV square and C equals to A epsilon naught epsilon R by D. Then substitute these values. Half area is 0.01 into epsilon is 8.854 10 to the power of minus 12, epsilon R is 4 into 1000 whole square divided by D is 0.01. 01 gets cancelled. 6 times this, 2 times this, then 17 microfarads. W in this case is 17.708 microfarads.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.